Okay, so we're going to copy the first four postulates to your postulates and theorems notes. Okay, now you might ask yourself, what's a postulate and what's a theorem? Well, today we're just going to focus on the postulate side, and we'll get to theorems later. But we can think of it this way. If you want to build something, let's say like a house or a skyscraper, you got to have a solid foundation in which to build upon, okay? Well, you can think of postulates kind of like the foundation of geometry, okay? Now, what they are facts in geometry that are accepted as true without proof, okay? So these are generally accepted truths, but we're not actually proving them. We just accept them, and that's the foundation in which we build upon. Now, later on, you'll learn that we're going to go through geometric proofs in which you have to prove things beyond a shadow of a doubt, but we build that based off of these postulates, okay? Now, the first postulate we have, see if we can bring this up. The first postulate we have, we're going to call P1. P1, okay? So we're just going to call the first postulate P1. It doesn't really matter, but that way it's just kind of easy to remember. And what it says is 2 points, determine a unique line. Okay, so the first postulate, the first generally accepted truth that we have says that 2 points determine a unique line. Okay, well, that should make sense. There's only one line that contains any 2 points. For instance, we can draw a diagram over here. Let's say I had the points P and the point Q. There is only one line that can go through both of those points, or go through both of those points. There's no other way around it. There is only one line that goes through both of these points. Okay? So any 2 points determine a unique line. Okay? So that's postulate 1. Postulate 2, P2. Okay? Now, postulate 2 says if 2 distinct lines, okay, so 2 distinct or 2 unique lines here, intersect, then I'm going to write just below here, their intersection is a point. Okay, so postulate 2 here says if 2 distinct lines intersect, then their intersection is a point. Well, that should make sense, okay? Let's just take 2 lines, and let's just call it unique by a lower cursive letter here. Let's say I have line, let's call this L, and line, let's call this one maybe M. Okay, so I have 2 lines here. They're 2 distinct lines, and their intersection, obviously they meet at some point. Okay, and this point, let's just call T. Okay, so if 2 distinct lines intersect, then their intersection is a point. It makes sense. Okay, postulate 3. Postulate 3 says 3 non-collinear okay, so 3 non-collinear points determine a, right beneath here, unique plane. Okay, so 3 non-collinear points determine a unique plane. Okay, well, if we go back and think about what does non-collinear mean, we know that that means any set of points that don't lie in the same line. So if I have 3 set of points and they don't all lie in the same line, then that determines a unique plane. Okay, for instance, let's say I had the points A, B, and C. Now we have to make this so that they don't all lie in the same line. Now earlier in postulate 1, we know, let's say I call this C, and let's call this B. We know that 2 points determines a unique line, but if we look at this, notice B does not lie in the same line as A and C, therefore A, B, and C are non-collinear, they all don't lie in the same line, but based on this postulate that we just wrote down, postulate 3, that means that these 3 non-collinear points determine a unique plane that contains all 3 of them, okay? All 3 of these points. Okay, so that's postulate 3. Postulate 4. Okay, postulate 4 says if 2 distinct, I'm going to run out of room, distinct planes intersect, then their, right below here, intersection maybe, there we go, then their intersection is a line. Okay, so kind of playing off the idea similar to when we had 2 lines intersected, they intersect at a unique point. Postulate 4 says if 2 distinct planes intersect, then their intersection is a line. Okay, now remember, a plane we can think of expands forever in all directions, but usually you'll see it drawn similar to like what a rectangle would look like. So I'm going to draw 2 planes here. Let's say I had plane M and plane C. See if I can make a decent looking plane. Whoops. Okay, and let's say I had another plane that's going to run through this plane. Oh, that is terrible. I apologize, my drawing is terrible. But hopefully it will get the point across. Okay, well notice it's going to cross, and where they intersect at, where these 2 planes are going to meet, is a unique line. Okay, so let's say I had the point A and point P here, and we said that one of these was going to be the plane M. See if I can get it. M, possibly. There we go. And let's call this C. Well, then if we look at plane M and plane C, where they intersect at is the line AP, okay? So what postulate 4 says, if 2 distinct planes intersect, then their intersection is a line, okay? So that's the first 4 postulates that we need to know. So after viewing this, please let me know what questions you have tomorrow, and we'll go over this further.